let us start our lesson with this application of refraction of light, and we will be doing this thing today, real depth and apparent depth. What we are going to learn in this chapter, we are learning very simple things, that is, when we view an object which is kept inside an optically denser medium and we are observing it from optically rarer medium, then we usually don't see the object at its real position, but we see that particular object at its apparent position, and that's why we are terming this as apparent depth and the real depth. Okay, so this we are going to know. This is nothing but an optical illusion, because light is traveling from denser to rarer medium, and you know that when light travels from denser to rarer medium, the refracted ray goes away from the normal, and that actually creates this apparent world. Okay, what we call it? Optical illusion. Okay, now just check it out. There will be a picture popping up just now. Okay, and I'll be explaining you the basic of this. So please remember, light is traveling from denser to rarer medium, and we are having this apparent depth or apparent position of the real object. We are not able to see the real position of the object. We are seeing the apparent position of the image thus formed. Okay, now please check the picture.
We can see the diagram which is explaining us about the real depth and the apparent depth. We are keeping an object inside a denser medium, which is water or glass, we can see, and we are watching it from air, which is optically rarer, and you can see how the path of light is traveling. Remember, we always draw our path of light where angle of incidence is 0, which you can see the ray passing from A dash. There will be no refraction, no reflection, nothing. It will go straight. But for the ray OB, there will be a refraction. The ray of light will bend away from the normal, and that way we can have this apparent depth. You can see the image I is situated at a depth which is lesser than the real depth. Okay, I hope you have understood this.
Now, since you have already seen the diagram about the real depth, apparent depth, and how light deviates from the interface of denser to rarer medium, everything you have seen. Now, using the diagram, we have a simple formula, and the formula is that real depth by apparent depth is equal to refractive index of the medium from where light is coming with respect to air or the rarer medium. That means, suppose you have placed an object in water. Okay, so you have placed the object in water, right? And you are viewing it from air. So it will be refractive index of water with respect to you. Clear? You can do a simple thing tonight. Just go to the washroom. If you have a bucket or you have a mug, whatever, fill it with water, right? And place any solid object inside it. You will see till the point the water is there, you will see that object what you have dipped will be appearing above, and when you just drain out the water from it and the object is inside it, you will see, okay, fine, it was that much deeper. Okay, so real depth by apparent depth is equal to refractive index of the second medium with respect to the first, and light is coming from second medium. Okay, sure, great. Now we want to calculate the shift. Now what is that? Shift means it is the real depth minus apparent depth. Okay, that means where the object was there actually and where the object is being viewed apparently, so there is a gap, and that gap is called shift. So this is shift. So what is that? Real depth minus apparent depth. That means S equals to real depth if I assume that is capital R, apparent depth if I assume that is capital A, so R minus A. Now we have this formula, real depth by apparent depth equals to 1 mu 2. Fine. So apparent depth is equal to real depth by 1 mu 2. Simple. So this value I will replace here, and then I will have a formula, very simple one. Shift S equals to R into, I am just taking R common, 1 minus 1 by 1 mu 2. Okay, So that is very simple. Shift is equal to real depth into 1 minus 1 by refractive index. Of which one? Refractive index of the medium where you have actually placed the object. Please don't forget this. Let us take an example. Suppose right now I was talking about to do an experiment at your home. I mean, just dip inside water, some solid, and just watch it out. You can understand what is real depth and apparent depth. Fine. Let us say we have taken that we have kept the object in glass. Okay. So what is the refractive index of glass? Is very standard. We know it's given in the book. It's 1.5. In fraction, it's 3/2. Fine. So let us calculate the shift of an object when it is placed inside the glass. You can see those paperweights where you can see there are a lot of patterns inside the glass. Okay, the spherical one. Same thing. So let us see where actually we see the patterns inside the glass. Okay. So S is shift. We have the formula written here. Okay, just now I discussed. So shift is equal to real depth 1 minus 1 by refractive index. 1 by refractive index is 3/2. So 1 by 3/2 is 2/3. So what is coming? It is R/3. So we actually see the pattern which is 1/3 of the real depth. We see so much closer. You can see, understand? So close. It's R/3, 1/3 is the apparent depth. Okay, so this is an example which clearly explains you about the concept of real depth and apparent depth. Alright? Great.
We can see the diagram of bending of stick on the board. And we have placed a stick inside water, you can see, and we are observing it from air. So we have taken a point from where we are taking two rays, light rays, coming to the air-water interface, and after refraction it is going away from the normal, and finally you can see that that point is appearing bit upward, and eventually considering the refractions from other points, the stick will appear to be bent from that end. Okay, so you can clearly see, I guess, that how the stick is apparently looking bent. So this is the diagram you should practice for your board as well as school exam. This is very important. Okay, do practice this diagram. So we have completed the section real depth, apparent depth due to refraction of light from denser to rarer medium. We have already completed all the examples, diagrams and everything. Now it's your time. Sit with your textbook, go through the section and practice the diagrams. There are solve examples, practice them also in your classwork, and then solve all the question answers in the exercise along with the numericals. I will come online for a doubt clearing session in our AccentUs group. Okay, till then, bye bye and be safe, stay safe.